Hi, hello, what's up? We're back at it again. This is still the great teacher Alcantara. A little sleepy now, but here's a set of like a refresher of what Cartesian coordinate plane is, like the rectangular coordinate system. So for this video, I would like to sincerely apologize. My voice is stumbling a lot because my god, my eye bag shows it. Basically, in this entire video, you can skip to the parts that you already understand, and you can check out the examples that we had in class for double checking. For those who haven't seen the lesson, you may watch the entire thing to prepare yourself for more practice. And we took it step by step with a lot of examples. So basically, make sure to take note of what you need to learn more about, so you can practice on that part. No need to watch the entire thing, and you might be sleepy as me. Probably you're watching this late at night, I guess. So yeah, so just skip to the parts that you need to go to. Peace out. Our goal or our target for this one is to identify the parts and the uses of the rectangular coordinate system. In a lot of references, there are a lot of names for this specific concept. They call it the Cartesian plane, the Cartesian coordinate plane, the Cartesian coordinate system. But for this video in particular, let's just simply call it the RCS, short for rectangular coordinate system. So let's start with its history. So we will be joined by Kura Sensei in this entire lesson so that it can have some different applications instead of just the regular kind of thing. So first, let us introduce the one behind the Cartesian coordinate system, or the RCS, which is René Descartes. So he is a French philosopher and at the same time mathematician behind the creation of the Cartesian coordinate plane, or the rectangular coordinate system. And rumor has it that the reason as to why he was able to create such concept is because during his time, unfortunately, he isn't as healthy as he was. So he spent a lot of time laying on his bed, and then for a moment, that based on this rumor, he was staring at his ceiling, and then he simply looked at how a fly from one spot to another on his ceiling. And because of that, the Cartesian coordinate system, or the rectangular coordinate system, was created. So to put into perspective, what you're seeing on your screen right now is the complete image of how or what the rectangular coordinate system looks like, and the parts and the details that are important to it. And if you have your paper with you, I would like to suggest that you try to do this also on your own. So you can draw a horizontal number line and name it as x, or the x-axis. And always remember, when it's a line, do not forget that there are arrowheads, because this extends infinitely on both directions. The reason why we just have -6 to 6, so that we can minimize the space and we can make more examples, okay? But again, since this is a line, the arrowhead extends from both direction, whether left or right, up or down. So the x line that we have, the horizontal one, we call that as the x-axis. While on the other hand, we have a vertical number line perpendicular to x that passes through the point 0, and we name that one as y, or the y-axis. So as you can notice here, there are two lines and they pass through one another. And these lines right here is, or these two lines, these two perpendicular lines, basically creates or showcases the concept of the RCS already. So basically, now that we have these two perpendicular lines, we can notice that they intersected at a certain point. This certain point where they intersected at is what we call as the origin. So you might be wondering, sir, what does the origin mean? From the name itself, if you look at dictionaries, the origin means that it's the beginning. So basically here, when we do our plotting of points later on, the origin plays a huge role as where we begin. Okay? So this is where we start. Where we start in terms of locating points. It's our point of origin. That's why it's named as origin. This is the point. Okay? And then now, when you plot points in the Cartesian system or the RCS, you might be asking, why are there two numbers representing it? Because if you remember, when you're plotting a point on a number line, it's just one number. But since it's a Cartesian plane, there are two lines here, the horizontal and the vertical. We make use of what we call as ordered pair or ordered pairs. Such ordered pair is represented by a parenthesis where we have the x, comma, and the y. And you might be wondering, why is it x, y? The x, again, is the horizontal position. So to put this into perspective, when we say horizontal position from the origin, it is the left or the right. While if we talk about the y, the ordinate, it says vertical position. This is the up or the down. So these are important details that you have to take note of. Why am I writing left or right for horizontal and up or down for vertical? So that you will not be confused later on when identifying what should be the sign, where should it be located, what's part, and so on and so forth. And also, please take note that the ordered pairs are also known as the coordinates. So if you're into games wherein there are maps, I think most of the shooting games, like I think in COD or other games like that, you will notice in the mini maps there are or in the audio of the characters they would say the words coordinates because they make use of that in real world, in maps, in locating places and so on and so forth. Okay. So basically, ordered pairs, the importance of this term, the reason why we also use this and not just the word coordinates, even though they mean the same, because of the word order. The order is that x comes first, followed by y. Okay? And it's a pair. X and y should be together. Again, to identify location in the Cartesian plane, it should be represented by two numbers. X being the position from the origin, whether left or right, and then y is for the up or down. Okay, so let's have some examples. So let's say that this is our blank Cartesian coordinate system, or the RCS, or the rectangular coordinate system. Let's say that we have a point located here, this dot right here. Let's name this point as E. And you might be wondering, where is this point located? Okay, wait. Where is this point located? Well, what you can do is you start from the origin, as mentioned earlier, because that's where we start. So from the origin, you will move first. It's your choice if you would like to go up or down, but remember, so that you won't be confused, the concept is that it's an ordered pair. You start with x followed by y. X is the movement horizontally, whether left or right. So from the origin, we go 1, 2. So what does that imply? Meaning, your x is equal to 2. So this will be 2. And now you might be wondering, what should be the value of y? So from this point, you will now go up. So this will be 1, 2, 3. So the location of point E is at 2, 3. So E is at 2, 3. So that's how it works. Okay? And next, let's say that we have a point somewhere here. Oh wait, it doesn't, it's not straight. Say it's somewhere here. So again, from the origin, that's where we start. 1, 2, 3, 4. But as you can observe, and as indicated in here, since we move to the left, the number for x should be negative. Okay? So our x here is negative 4. And how about for the y? So from this location, we go 1, 2. So we went up 2 times, so that is still positive. So it's negative 4, 2. And let's name this point as, let's say F. Next, let's say that we have a point here, and let's name it as G. Point G. So again, we start horizontally first so that you won't be confused. So we will go 1, 2. 2 units to the left. So that means that G is somewhere in 2 as for x, and for y, we go down. So 1, 2, 3. So that means that our G is at 2, negative 3. sorry, -2, -3. I forgot the -2 since we went to the left side. It's -2. We went down, so that's -3. Now, let's say that we have a point somewhere here. And if you move there from the origin, you go 1, 2, 3, 4 to the right. So that's positive. Let's name it this as H. That's positive 4. Then we go down 1, 2, 3 units. So that's -3. So as you can notice here in these points, this is how you plot them or how you get their location. So you always start from the origin and always remember that if you go to the left, it's negative. If you go to the right, it's positive for the X. While for the Y, if you go up, it's positive. And if you go down, it's negative. Now, the important detail here is that these points have particular locations. So as you can see here in the image itself, the two lines, these two perpendicular lines in the plane, divides the image into 4 different quadrants. From the name itself, quad meaning 4. So it's 4 parts of regions where the points can be located. That's why I gave 4 examples here. The first part, which is this one right here, these are all positive, meaning to say the X and the Y here are both positive. And we call this as quadrant 1. That's quadrant 1. While here, left to it, all of the points here, so you can notice, the X is always negative because the point from the origin, you went to the left side. But still, it's above, so it's Y. So this is quadrant 2. While for this one right here, below, it's downwards from the origin and also on the left side. So the X is negative, same as the Y. We call this as quadrant 3. While on the last part, it's on the right side from the origin, so the X is positive, but it went down, so the Y is negative. And this is quadrant 4. So for you to not be confused, simply remember that from the upper right, you go counterclockwise in terms of the numbering. So quadrant 1, we start from there, counterclockwise, you will have quadrant 2, 3, and 4. Quadrant 1, all is positive. Quadrant 2, negative X, positive Y. Quadrant 3, both are negative. And then for quadrant 4, for your ordered pair, the X is positive, the Y is negative. So that is the parts of this given Cartesian coordinate system. Now you might be wondering, sir, what if there is a point located on this part? Excuse me. Is it part of quadrant 1 or is it part of quadrant 4? Well, the answer is actually neither. This point right here, the color red point that I indicated, is part of, again, what we just discussed earlier, of the x-axis. So if you stumble upon this kind of example, this means that this point lies or is on the x-axis. Similarly, if you have a point somewhere here, since it's not in quadrant 3 nor 4, it's on the y-axis. Okay, so that's the case. So points are not only in the quadrants, but they can also be on the two axes or the two lines that we have, either x or y. Okay, so to summarize it, this is our definition of terms. You may have a copy of this one so that you won't be confused. Always remember, quadrant 1, all is positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both are negative. Then quadrant 4, x is positive, y is negative. So that's how it works. Always remember, ordered pair has different kinds of values or different kinds of pairs. We have the both positive, both negative, positive, negative. And again, we also have times wherein the points can be located either on the x-axis or the y-axis. So basically, if you are trying to identify on what part of the plane are the points located, you can have 6 different answers, either in the quadrant 1, 2, 3, 4, x-axis, or the y-axis. Okay? So those are the parts as indicated here. So let's try to make use of an example. As you can see here, the point M is located at 4, 5 from the origin, meaning 4 units to the right. That's why it's positive 4. Then for 5 units up, that's why it's 5. Similarly, if you do point A, it's negative 4, 5. So from the origin, you start counting 1, 2, 3, 4, since it's negative 4. And then you move up 5 times because y is positive. So 1, 2, 3, 4, 5. So there's the point here. This is point A. For point T, it's located at negative 4, negative 5. So from the origin, we go 4 units to the left, 1, 2, 3, 4. Then 5 units down, 1, 2, 3, 4, 5. So we can have the point here. And this is point A. A is at negative 4, negative 5. Next, let's have H. That's 4, negative 5. From the origin, 4 units to the right, 1, 2, 3, 4. Because it's positive. So 5 units down naman because it's negative, 1, 2, 3, 4, 5. So your point is right here. And this is point H. Sorry, wait, my handwriting is wrong right now. I don't know why. Wait, let me just correct it. This is H at 4, negative 5. And also correction, this is not A. This is supposed to be T. Okay, so that's how it works. Let's have one more example. Say that we have the following. For H, it's 2, 2. So from the origin, 1, 2. 1, 2. So this is your H at 2, 2. Next, how about the O? From the origin, 1, 2 because it's negative 2. Then 1, 2 because it's positive 2. So O is at negative 2, 2. While for P, we go to the left 2 units, 1, 2. And then 2 units down, 1, 2. So there should be a point here. This is point P, negative 2, negative 2. While for point E, from the origin again, 1, 2, because it's positive 2, but we go down because it's negative 2. So there should be a point here. This is point E. This is 2, negative 2. Okay? As simple as that. Now let's try to apply these concepts in word problems. So let's say that we're joined by Core Sensei in this journey, and he's asking our help for identifying the location of his students. So first, we make use of Core Sensei as in the origin so that we know where to start. So where Core Sensei will go next. So if Core Sensei tries to identify the location of the orange-haired girl here, so he will start from the origin. So from the origin, we start 1, 2 to the right. So that's our first number for X, 2. Because we went 2 units to the right, but for us to reach the orange hair girl, we have to go 1, 2, 3, 4, 5, 6 downwards. So the location is at 2, negative 6 for the ordered pair. While for the quadrant, it's in quadrant 4. Why is it in quadrant 4? Again, we start from the upper right, that's our quadrant 1, and then counterclockwise. Now let's try to find Nagisa. So we go from Core Sensei 1, 2, 3 to the left, so negative 3 for X. Then we go 1, 2, 3, 4, 5, 6 up. So it's negative 3, positive 6 for Nagisa. And he's located at quadrant 2. While for Karma, we move 1, 2, 3, 4, 5 units to the left. So it's negative 5. And we also move 1 unit to the right. So it's negative 5, 1. And again, this is in quadrant 2. Karma is in the same location or same space as Nagisa. While for the glasses girl, we go from Core Sensei again. We go 1, 2 to the right. And then we go 1, 2, 3, 4 upwards. So it's 2, 4, and it's in quadrant 1. As easy as that. Next, the green-haired girl from the origin, from Core Sensei, 1, 2, 3. So the 3 is for the X, but it's negative 3 because we went to the left side. And then we go 1, 2, 3. It's negative 3 also because we went downwards and it's in quadrant 3. Similarly, the short-haired man, the gray-haired man, we go 1, 2, 3, 4 units to the left. So that should be negative 4. And then we went 1, 2, 3, 4, 5, 6 units to the left, downwards. So it's negative 4, negative 6. And with that, we can say that the location of this guy right here is also at quadrant 3. While for the short-haired woman, we go from Carsense 1, 2, 3, 4. 4 units to the right. Then how many units down we go? 1, 2, 3. So it's at 4, negative 3. And it's at quadrant 4. So as easy as that, you can identify the location and then at the same time, identify at what quadrant or what part of the Cartesian coordinate system is it located. Always remember, it's an ordered pair. It starts with x followed by y. Now, let's say that we have this given word problem where Sensei wants his students to understand that even at his worst day, he is unbeatable. So for every misassassination, he gives his students 6 word problems to answer. If the students answered 42 word problems, how many misassassinations took place? So this kind of example, you don't have to overcomplicate. You might be saying, sir, what's the application of that from the previous lesson? Basically, I want you to answer the word problem using what we call as a table of values. This table of values is basically the values of x and the values of y that you need to make use of that you will grab later on. To continue, based on the word problem, it mentions here specifically that for every misassassination, he gives his students 6 word problems to answer. Meaning, 1 misassassination, you get 6 word problems. And since x is used for 1 and y is used for 6, this could be written as 1, 6. Similarly, if there are 2 misses, we'll get how many word problems? 12. And this is located at 2, 12. And again, if you have 3, you'll have 18. So it's a 3, 18. If you have 4, it will be 24. And that will be at 4, 24. And lastly, if you have 5, that will be 30. And it will be allocated at 530. So with that being said, you now have 5 different ordered pairs. And you may start plotting it on the Cartesian coordinate plane. Now, the concern is on the right side, the graph is a little small. So what you can do is you can extend it on your paper, or you may even try to make a bigger copy of your own. So basically, what we can only see here or plot is 1 and 6. So it should look like this, okay? So again, you may draw a bigger or a longer number line so that you can graph the other parts, okay? Because this is until 24y, or 30 I mean. Okay, so that's the reason for that. Now, when you're dealing with word problems, always remember that you have to answer the word problem. So the question in the word problem is that if the students answered 42 word problems, how many misassassinations took place? So you may do different kinds of analyzations in here, and you will arrive with the answer that it will take 7 students to do so. And with this, we can actually also answer and try to formulate an equation as to how we could solve for the other possible values. Like for example, what if there are 8 misassassinations by the students, like 8 students miss, or so on and so forth. So based on the pattern here, we can notice that for every miss, it increases by 6 word problems. So we could make use of that as a way for us to create the equation that is y is equal to 6x. And for you who might be wondering, why is it y is equal to 6x? Because let's say that x, as mentioned in the table of values, that it is in relation to the students who missed their assassinations. So 7 students missed their assassinations. Basically, if that's the example, you can substitute 7. So we can have y is equal to 6 times 7. So the answer there is y is equal to 42. The 42 is the word problems. And again, as you can see here, y is in relation to the word problems. So we can formulate an equation based on the pattern using the variables also that is presented. So that's all we have to make sure. We look at the variables mentioned and at the same time the pattern that we managed to find. We can also use this with some other examples. So let's say that we have this example with Irina Sensei, and now we have her wherein she wants her students to learn how important it is to learn the English language for communication purposes. So for each day, 3 unique vocabulary words are tasked for spelling. How many unique words will the students spell within 1 week? And now we again have a table of values here, and we have the number of days wherein we have where she gives spelling exercises. So for the first day, as mentioned in the word problem, for each day there are 3 unique vocabulary words. So for the first day, that's 3. So our ordered pair is 1, 3. For the second day, we'll have 6 all in all. So basically, if you add 2 days, for the first day you got 3, the second day you have another 3, so that's 6 all in all. So for 2 days you have 6 unique vocabulary words, so that's 2, 6. This will be 9, that's 3, 9. This will be 12, this is 4, 12. And then this will be 15, so 5, 15. So that's how it works. So again, if you're struggling with creating your own Cartesian plane that is bigger than the one that presented it on the screen, you may use Desmos or GeoGebra, and you may test it out on how to graph points there. Because in this example, we can only graph the first day, which is 1, 3. Based on the space provided. Sorry for the lack of bigger Cartesian plane. You can also have 2, 6 here. This is 2, 6. So you just continue the rest, the 3, 9, the 4, 12, and the 5, 15. So if you're being asked the question, how many unique words will the student spell within 1 week? So in a sense, if it's in terms of school week or like the weekdays only, the answer is 15. This is not supposed to be word problem, just spelling, sorry. I wasn't able to change it. But again, if, for example, again, it's just weekdays, the answer is 15, depending on the context. But what if Irina Sensei decided to give assignments, like during Saturday or Sunday? So we could say that the answer is possibly 21 words. So that could work also. And again, how do we create an equation using y and x? Again, the x and y. For every unique word, we get 3 times the number of days. Okay, so it's 3x. Like for every day, we multiply to 3. So let's say again, there's 7 days. Let's say that x is equal to 7, the days. So y is equal to 3 times 7. The answer is that there will be 21 words. So that's how this works. So basically, for simple examples like this, don't worry, in the next lesson in linear functions and equations, we're gonna deepen our understanding of that. But with simple examples like this, most of the time it's just like y is equal to 3x, y is equal to 2x, 4x, and so on and so forth. When it is about word problems similar to this one. Now let's have our last example. Let us join Karasuma Sensei now. So let's say that he's making the students learn about different techniques to corner Koro Sensei. Every student has to present 4 different ideas regardless of repetition. How many ideas will be available if there are 7 students involved? So let's say that there's 1 student. Again, the word is every student. So each of them will present 4 ideas. So that will be 4 here. Then if there are 2 students, there will be 8 all in all. There will be 12 all in all for 3. This will be 16, and this will be 20. So our ordered pairs are as follow: 1, 4, 2, 8, 3, 12, 4, 16. Then we can have 5, 20. So if ever you're struggling with answering the word problem, you can go and create the equation first. We notice that the pattern is its multiples of 4. So we could say that the equation is y is equal to 4x. So let's check it out. It says here 7 students tried to give their ideas. So let's say that x is equal to 7. As mentioned here, again, the student is x. Okay, so y is equal to 4 times 7. So the answer is that there will be 28 different ideas, or even though it's repetitive, basically 28 ideas from the class itself. Again, sorry for not updating the slides. Apologies for that. So basically, again, do not panic with this one. You already know how to plot points,
Do not put pressure to yourselves. Just do it step by step. In the meantime, not pressuring you to draw lines yet. We're gonna do that in the near future. So for now, that's it.
Yes, finally that ends our video lesson for the rectangular coordinate system. And as always, you may check out the other videos for review that you need to check out depending on what you need to review for, okay? Always remember, no need to overthink things, no need to overdo it. Just make sure to do what you need to do. Okay? And again, in case you don't see me, it might be a while again, but who knows, maybe it's soon. So always remember what's up, and that is respect, okay? And in case you don't see me, good morning, good afternoon, good evening, and good night. I mean, bye-bye. Bye.